Okay, awesome. Welcome back, class. We're still in the same project. I was just messing around with lighting because I always do that. It's always just fun to play around with lighting. Okay, so because I don't want to waste you guys' time, let's get cracking. I will exit out of my play mode for now, although I do like the purple that I'm getting. Okay, exit. And what I'm going to do is I'm going to pop into my content drawer. I'm going to go into my localized fog folder. I'm going to right click. I'm going to create a new material. I'm going to call this am_fog volumetric. I'm going to open her up. I came in over here. I'll make this go. Come on. There we go. And I'll be popping back and forth between this window and, the actual level to see what we're changing. But what I'm really going to be doing is I already have a completed version of it right here. And we took a look at this a little bit last video, but I'm going to be recreating this from scratch for you guys. And what I'm going to be doing that wasn't covered, I think, in the CG dealer video is, the person went through and made most of these stuff. They kind of didn't visualize what's happening while they're doing it. So right now we can see on screen the material preview. This is kind of what the localized fog volume is doing. We're going to end up with a texture that's going to be running along the base of our localized, the base of whatever mesh that we're giving it. So this is like a collection of cloud textures, these two right here, connected to a panner that's panning it across the XY coordinates, and we're masking out the top portion of it, or else it would just fill out the box. So essentially, black is not visible, white is. And this masking, so this section up here is the fog texture. This is how we're choosing what cloud textures are going to be running across the screen, at what rate. That's what the panner's doing over here. I'll go through this in more detail. I'm kind of choosing the texture size, so how clear our textures that we're giving it are, whether they it's crisp and clear, or we can reduce it and have it be a bit choppy, which I think saves on some kind of computational-ness. But it's really combining, how we're letting the textures flow through our mesh and this fog boundary, which is kind of setting how high the textures can rise, or how much of the volume that they can fill up. And that's what's happening down here. But we will take a look at that as we build it. I think if I preview this one, we can see right now, previewing this node right here, the black is let's see, we're creating a fog mask, whereas white is where things can be visible and black is not. And we can adjust how far up this is going to be able to go. So if I default, I think this should... We're going the wrong way. There we go, yeah. We're messing with what is known as the extinction level. So how much of the fog is going to be visible, how much of it's going to be, extinct. But yeah, let's let's set this back to where it was so I don't break anything. 1.5. There we go. Let's try building this from scratch, and I'll try to walk you through as best as I can. Okay, let me make sure I didn't break anything. I did not. Yay. Okay, let me move this over here. And lovely. Okay, so we're gonna start with the fog boundary kind of portion. So this is choosing like how much of the fog is going to be visible, how much of it's going to be, extinct and whatnot. And essentially we're just messing with the height. So fog is supposed to settle at like the ground, like at the floor. And I'm assuming if it's like, less dense, if it's really dense fog, it's going to be at your ankles or whatnot. But if it's the fog kind of like not as dense, it'll it'll rise in height. So that's what we're trying to do first. Before we do that, we're going to set our material to a few different things. Right now it's set to opaque and default lit. Default lit's fine. I'm going to change it from opaque to additive, which I think is necessary if we're doing things in volumes. So let me switch my view to gray because I don't like the Unreal headquarters and background. And let's see. First thing I want to get is right click and type in looking for world position, absolute world position. There we go. And if I look to see what this node is doing, I can click this little play button to preview it. I'll change my default preview to a cube. As far as I understand it, and I can bring up what Unreal's documentation says, is here it is. Oh, what the? Come on, mouse, do your thing. World position. So absolute world position, if I'm understanding correctly, is that it's painting the cube in these different colors. What it's doing is it's let's see, world position express outputs of the position of the current pixel in world space. So each different paint on this square is a different vertex, I believe, and it's just visualizing it here. This is a really cool thing to check out if you're confused about what these nodes do. Even with this, I think it's still very confusing. But yeah, we're just trying to, I believe, what we're doing right now is that we're trying to mask, create a 3D mask for whatever object mesh that we're giving it. Let me bring this back up. So let's see. I will drag off from its XY coordinates. I want to transform this into local space, transform position. There we go. If I preview this, is it going to do anything? It's going to look the same, I believe. Yeah. I will set this to its source is going to be absolute world space, and its destination is going to be the local space of the mesh object that we're putting it on, because we're going to be using like a cube for this to render our fog. That's going to be our local fog volume. And let's see, next I'm going to want to create a custom node, custom node, custom, here it is. And here we can enter in, I believe this is HSLS code. But we're just trying to get like the bounds of the mesh that we're putting it on. So let's see, in here, I'm just going to actually copy the code. I'm going to create a variable, call it size. And what I'm going to do is, scroll it. I want to get primitive data parameters. I hope I spelled this right. Well, it'll bug out if I didn't. Local object bounds max.xyz, and I'm going to subtract this from, if I got its max, I'm subtracting it from its min. Scroll over to this one, and for max type in min. And what I'm trying to do is trying to get the size of the mesh that we're gonna put this material on, so it's going to determine how far, like how do we modulate the height of the fog. We're going to need to know like how big the object is. Is that all good? Yes. Now I need to add a return node. Return, and I'm just going to return the min. Okay, did that bug out? Let's see. If I typed it in wrong, it should tell me down here. Yay, I'm all good. Okay. So let's see. So from the transform position, I want to subtract from the local bounds, and I think I have to, let's see, float 3, that's fine. I'll call this local bounds. Inputs, additional inputs, I want to be able to get the size. So size, and size is a vector 3. Well, float 3. Is that correct? Did I mess up my brain doing that? No, float 3, I'm right. And that's the size here. Okay, and we can see it popped up. Yay! Okay. So, actually I would prefer to rearrange these, but I guess beggars can't be choosers. Subtract the local position and its size, and no, I'm wrong. There we go. I want the return to go into here and see what that looks like. This is going to mean nothing. It tries to represent what we're doing, but this kind of means nothing. If I switch this to the square, this might make a little more sense. If I preview this, we can see like the light blue is at the very top. And now that we've subtracted the local bounds from the local position, we're kind of just getting like the top portion of the mesh, I believe. Again, how they're doing the preview doesn't make sense to me all the time, but it is trying to be as helpful as it can be. Okay. But this will make sense in like 2 more nodes. So if I, for my subtract, add in a divide, and then divide its size, and make this better. Okay, Q on my keyboard, make it straight. There we go. And then from this, I'm going to mask out. Mask out the B channel. So if RGB. So if we're messing with a cube, which is what we're looking at right now, RGB is the same, I guess, XYZ. So if we're masking out the B channel, we're trying to get just the height. So the Z, as we can see right here. So if I play this, we can see we've created a mask. Black will be not visible. White is what we're messing around in. So through this magic, we have created a mask already, which is very cool. And that's pretty much what we were trying to do for this. And if I want to be able to modulate this 3D mask, I can add a multiply. Put this into the second channel. I can play this. Since we're multiplying by 0, this should be all black. But if I want to be able to, change the height of the fog, I can add in a scalar. Jesus Christ, I can't spell. Scalar parameter. I'll call this height. And I'll set this to be 1.5. 1.5. And we can see now if I mess around with the number, we can kind of adjust our mask at will. Oh, cool. I'll pause here and I will come back in a sec with the rest of it.